Hello everyone. I and Larry have worked on the project which we call COVID-19 and misinformation. As a part of the project, our main goal is to create machine-generated tweets using our model on COVID-19 disease and educate people on how to distinguish between human-generated and machine-generated data on the internet. As we know, COVID 19 has been declared as a pandemic by WHO. It does not come as a surprise that there are over 5.5 million tweets as of April 23rd, 2020, about the disease. As coming to the effects in times of a pandemic, misinformation creates a lot of panic, poor physical and mental health outcomes, and causes media fatigue. While researching to find data on fake news and misinformation about COVID 19, we realized that there is not enough published data. There is not identified fake news about COVID 19, and this mostly stems from the fact that the virus itself is a very novel concept which is still being researched. As for the data set, we found the data set on Kaggle and GitHub, which was basically a collection of tweet IDs, which we hydrated, cleansed, and extracted the tweets which were in English language and did some basic textual formatting. Moving on to the machine learning model, which will predict the machine generated tweets. This is what the model functions like. We start with importing the libraries, fetching and cleaning the data set, vectorizing the text, which is giving each character a numerical representation, creating training examples, creating training batches, defining our model and training our model, and then predicting the tweets. In the model we use RNN, which is a recurrent neural network. The RNN model has three layers: an input layer, a gated recurrent unit, which is another a neural network, and then an output layer. We started by training with 20,000 tweets, and the goal is to be done training with 1 million tweets by the end of this week. We played with different parameters like temperature, optimizer, number of epochs, which is number of training cycles. This is basically the different parameters that are associated with a machine learning model that can be changed to change the model outcome. This is a snippet of what our code looks like. We did some text processing, vectorizing the text, and then moving on, we'll have creating training examples by moving the text character by character, creating training batches, then defining different layers in our model, defining the entire model, then training it for 30 epochs, and then we do the predictions and then generate like a small graph of lofts versus epoch. As for the results, we trained with three different optimizers. The Adam optimization outperformed all of them. We trained for 50 epochs. We saw that around 24 to 30th epoch, the loss started to increase, which is not good. So for the temperature parameter, we saw that the lower the temperature values, the better results we got, the more predictable the tweets were, which is what we want. As for the user-facing component, we developed a website which are using to crowdsource the prediction credibility of our generated tweets. So on the right, you can see there are three tweets. The first one is a little bizarre. But does follow the grammatical constructs. The second one has a link, some hashtags, and a phrase, which is okay. The third one is even better. It has a person tagged, some hashtags, then a phrase "not to believe," and then a link, and it does have some emojis, which is a common form of expression on social media. So yeah, on the website, people can are shown a mix of both human and machine generated tweets, and then they're scored based on if they identified a tweet correctly as human versus machine generated. The front end is done as React and the back end in Python and Firebase. As for the takeaways, generating fake text is very easy. That's what we learned. Also, that misinformation about any topic is very widespread. The languages used on social media is very different from the constructs for the same language in other communication formats. Training a learning model is as important or maybe more important as how you design your model. And curriculum training gives you more control on how you train your data and thus yields you better results. Finally, we would like to thank our professor, Dr. Donna Gurari, our TA Florian, and our friends and colleagues for making this learning experience so much fun and helping us throughout. Thank you. Stay home, stay lives, save lives.